Much of the code you ship this week, you will not read. Not because you're careless, because there's more of it arriving than there is of you. So here is the shape of what we're covering. Between a change in production sit 8 strata in 3 bands, cheap machine checks at the bottom, a gate in the middle deciding what a person ever sees, human judgment at the top. We'll walk that stack, then ask 4 questions of it: how you build it, what it costs to run, what breaks first at scale, and how you change it once it's load-bearing. Start with load. 42% of committed code is now machine written. The projection for next year is 65. And here's what that did to the top of the stack, the part made of people. 96% of developers say they don't fully trust that the code is correct. 48% always check. Nobody chose that gap. It is what the shape does under load. The median time a pull request spends in review is up 441%. And machine-written ones wait more than 16 hours just to be picked up. And the share of pull requests merged with no review at all is up 31%. That's Pharos, across 22,000 developers and 4,000 teams. So the obvious story is that reviewers are drowning. Too much code, too slow to read. But look at the second number, because it says something different. Once a review actually starts, AI-written pull requests get through it faster than human ones. Linear B, across 8 million, pull requests, 194 minutes against 252. And they're 2.5 times larger. Reading isn't the bottleneck. Getting looked at is. What broke is the allocation. Who looks at what, and what gets through unlooked at. And when a queue exceeds its capacity, it doesn't slow down gracefully. It starts, dropping things, and dropping is silent. 77.5% of merged agent-written pull requests were approved by whoever submitted them. For human pull requests, that figure is 57.6. So the habit isn't new. It just got a lot more common. But almost nobody is arguing about that. They're arguing about the code itself, whether the machine writes it well or badly. That argument is loud. It is 2 years old, and both sides of it are measuring the wrong variable. Take the pessimist case first, at its strongest. Vericode has been running the same security benchmark across models for 2 years, more than 150 of them. They're finding, in their words, 2 years of revolutionary model releases. Move the security needle from approximately 55% to approximately 55%. GPT 5.1, Gemini 3, Claude 4.6, all inside the margin of error. OpenAI's reasoning models did better, around 70 to 72. That's still a 30% vulnerability rate, and Backbench found something sharper. Of the programs these models generated that were functionally correct, the ones that passed, researchers successfully exploited about half. Now the optimist case, also at its strongest. DARPA ran a cyber challenge where AI systems analyzed 54 million lines of code. They found 86% of the planted vulnerabilities and patched 68%. At the semifinals, those numbers were 37 and 25, about $152 per task. And Meta has a system called Radar that has reviewed over 500,000 diffs. Reverts run at 1, third the rate of unreviewed by Radar diffs. Production incidents at 1/50th, on the diffs it picked. Though when Meta benchmarked automated patching outside of competition, only 5 to 11% of the fixes survived verification. Generating a patch is not repairing one. Both of those are real. So which is it? Neither. Look at what changes between them. These aren't the same experiment run twice. Nobody has run that one. What moves is the job we gave it. Author, unsupervised, or verifier inside a gate. Unsupervised author, with nothing scoring it before it lands. Flat, mediocre, not improving. Verifier inside a gate. Scored, and held back if the score is bad. Genuinely good. And Radar's numbers depend on the gate completely. It only auto-approves diffs it has already. Scored as low risk. That's not a caveat. That's the mechanism. The machine verifies well. It authors mediocrely. We deployed it the other way around. It writes, and you review. Ask 10 engineers what verification means, and you'll get 10 different corners of it. One says code, review. One says tests. One says the security scan that blocks the build. They're all naming a piece. Here is the whole thing. Think of it as a cut section. cheapest and most automatic at the bottom, most human and most expensive at the top. At the bottom, static analysis. Linters, secret scanning, infrastructure checks. It decides whether something is obviously wrong. It's nearly free and it runs on everything. Above that, automated tests and invariant enforcement. It decides whether the thing does what it claimed and whether it broke a rule the project holds. Then, risk stratification. This is the gate. It decides which changes are allowed past without a human at all. And it's the stratum most teams have never explicitly built. Above it, automated remediation. Not finding problems, fixing them. Then cyber reasoning, proving a vulnerability is real by exploiting it. Then reviewer routing, who gets asked. Then the human conversation itself. And at the top, approval. What the word approved is actually permitted to mean. Now the part that matters. Draw each of those bands at the thickness of how much work it can absorb, and the human bands are thin. Very thin. Almost everything this layer can do at volume, it does. Below the waterline. There are 4 more areas we're naming and not teaching today. How diffs are presented, how. Verification tooling gets trialed, how change history is audited, and how reviewers are selected at. Org scale. And 2, we're deliberately not covering, because other episodes own them. Supply chain and dependencies. That's episode 7, part 2. Architecture and compliance. That's episode 4. So, 8 strata. If you had none of them, which do you build first? Google once ran a product where more than 80% of production pushes carried a bug that affected users. Not a startup. Google. What they built matters less than the order these decisions have to be made in, because they only fit one way. That order is ours, not theirs. First, what is allowed through without a human at all? That sounds like the last decision. It's the first, because every other decision is downstream of it. Until you've said which changes don't need a person, every change needs a person, and you've already lost. Second, what approved is permitted to mean. Is it I read every line? Is it the automated gates, passed and I checked the shape? Those are different promises, and a team that hasn't chosen makes, both at once, inconsistently. Third, what enforces that automatically? The tests and invariants that make the promise true without anyone remembering to keep it. Fourth, and only fourth, the cheap tier. Linters, scanners, the stuff that catches the obvious. Everyone starts here because it's easy. It's the least load-bearing thing on the list. Now, the decision inside Google's program that most people skip past, they refused to mandate it. It reached over 1,500 projects, and it got there by teams opting in at levels they chose. A mandate would have produced compliance. They wanted adoption. One more thing, and it is the one that catches people out. Best practice will contradict itself. SQLite. One of the most rigorously tested pieces of software on Earth states plainly that pursuing the strictest form of coverage and running fuzzers compete for the same machine budget. They chose fuzzing. Somebody has to make that call. That somebody is the job. So it exists. What does it cost to keep running? It's paid in attention, and attention has a measured limit. SmartBear's classic Cisco study of code review found that reviewers working slower than 400 lines an hour were above average at finding defects. Above 450 lines an hour, defect density came out below average in 87% of cases. Past the limit, you're not reviewing faster. You're producing approvals. That study deserves its caveats, and you should hear them. It was published by a vendor. It had no control group. The headline numbers rest on 300 reviews, read by hand out of 2,500, and 21% of reviews were discarded from the analysis. But there's a second number in it that nobody quotes. 61% of reviews found nothing at all, and that turns out not to be an outlier. In Google's own research, 2 developers out of 44 said a review comment had ever found a bug for them. In Microsoft's, comments about defects were 14% of review. Comments, 4th out of 9 categories. And in the study that should worry you most, Linux kernel maintainers caught 56.6% of patches that introduced a vulnerability. For concurrency bugs, 19%. That's expert review on one of the most scrutinized code bases in existence, catching about half. The kernel's technical advisory board disputes that reading. Their position is that their review process worked as intended. Both are on the record, and you should know both. But here's the uncomfortable version. We didn't lose a safety net to AI. We found out we'd been standing on one that always had holes this size, and the volume is what made us look down. You cannot buy more attention. You can hire slowly, and you can burn people out quickly. Neither is a strategy. So the only real variable is where it lands. Picture the attention your team has as a fixed quantity. One reservoir, refilled daily, no more than that. Ungated, every change draws from it equally. The trivial dependency bump and the change to the payment path make the same claim on it. The reservoir empties in arrival order and arrival order, has nothing to do with risk. The dangerous change gets whatever's left, which some days is nothing. Gated, the claims get sorted before they draw. Most changes never reach a person. The reservoir gets spent almost entirely on the small set where judgment actually changes the outcome. Same reservoir, same volume arriving, completely different result. That's what risk stratification is, not a productivity feature. The only mechanism by which a fixed attention budget survives a variable volume input, and that merged with no review number from earlier, that's what an unsorted queue does on its own. The bypass builds itself. You don't decide to skip review, you run out, and skipping is what running out looks like. That is exactly where Dora's data lands. In 2024, they found AI adoption associated with lower throughput and lower stability. By 2025, with about 5,000 respondents, throughput had reversed. It was positive. Instability did not reverse, and Dora's own reading of it is not the code is bad, it's this. Without robust control systems, an increase in change volume leads to instability. That's a control problem, not a code problem. Now the hardest one, and the one that always gets dropped, changing a verification regime after it's already load-bearing, not building it, changing it while code is moving through it. There are 4 documented cases worth knowing. Google adding a testing regime where there effectively wasn't one. Microsoft deleting an entire role. The dedicated software engineer and test in 2014. Not adjusting a process. Removing the people whose job the process was. LLVM moving off Fabricator to GitHub. And that one comes closest to the question the others. Ignore. What happens to the reviews still in flight when the regime changes? It gave them 1 month of overlap and then said nothing. That is the actual difficulty, not the new system, the changes, already halfway through the old one. And Chromium moving from Rietveld to Garrett. 4 cases. Now the part that should bother you. There is no controlled measurement of what any of those migrations did to the rate at which defects escaped to production. Not one. And there is no published account, anywhere we could find, of a team migrating a verification regime specifically to handle AI code volume. That is the thing every team watching this is doing right now. We found that absence twice by 2 different methods. A structured map of this layer marks the source is silent on migration for half its areas, and a separate pass through the code review. Literature found the same hole independently. 2 methods converging on the same emptiness is a finding, not an excuse. So if the literature is empty, what do you hold on to? Not the number everybody reaches for. Test coverage. The moment coverage becomes a target, it stops measuring anything. Coverage counts which lines executed while the tests ran. That's all it counts. It does not know whether anything was asserted about those lines, whether the assertion was meaningful, or whether the behavior that matters was exercised at all. So when a number gets attached to it, 80%, 90, whatever the policy says, the cheapest way to hit that number is to write tests that execute code without checking it. The measure climbs. The thing it was measuring doesn't move. That's Goodhart's law, and verification is where it does the most damage, because a high number here actively buys confidence. Even Fowler's test pyramid. The most cited shape in testing comes with his own later. Qualifications that it's a heuristic, not a quota. The shape was never the point. And this trap generalizes past coverage. When researchers gave developers automated fault, localization, a tool that ranks the lines most likely to contain the bug, there was no significant speed up. A better ranking made developers slower. and participants spent 61% of their time inspecting statements after they had already looked at the faulty one. A better signal is not automatically a better outcome. Someone still has to decide what the signal means. That deciding is the job. Let me separate what the evidence establishes from what it doesn't, and from what's mine. Established. The split is real, and it tracks the gate, not the model. Flat and mediocre outside. 1. Measurably good inside 1. No one has run the same system both ways. Established. Review has a rate limit, and past it, you're producing approvals rather than reviews. And human review was weaker than its reputation, long before any of this. Established. And this one goes against the popular story. The controlled trials inside real. Companies did not find the collapse the story predicts. 3 enterprise trials across 4,008, 167 developers found reviewers approving about 10% more of that. Work, not less. And no evidence that code quality at Microsoft declined. In the same trials, build. Success fell at Accenture. And 3 corrections, because you have probably heard all 3. The 46% figure, the one everywhere, is a GitHub marketing line from February 2023, not a measurement. The current source number is 42% from Sonar this year. Say that. 1. And say who counted. The claim that AI doubled code churn, code rewritten or thrown away days after it was written, was a projection, not a measurement, and it failed replication. Across 200,000 repositories, researchers found no general increase. GitClear published the original, and GitClear sells the metric. And Meta's study, the one-sided everywhere as proof AI slows you down, 16 developers, more than half of, whom had never used the tool, working in million-line repositories they'd known for 5 years. Meta's own page now carries a banner saying the results are out of date. Then my read, and it's a read. We deployed this backwards. The job isn't to read harder. It's to stop spending judgment where the machine is now better than you, and spend it on the one thing it cannot do, deciding what correct means for this system, and then building the gate that enforces that decision, so the deciding only has to happen once. 6 things this episode could not settle. An investigation with no gaps is hiding them. 1. Whether AI-authored code escapes to production at a different defect rate than human-authored code. Nobody has measured it. Both sides of this argument are running on proxies. 2. What migrating a verification regime for AI volume actually costs. No published account exists. 3. What merged means for agentic pull requests. The researchers who measured merge rates say, plainly that flawed contributions still get merged, and rejections are often social. Inactivity, missing tests. Merge rate is not a quality measure. 4. Whether that 400 lines an hour envelope still holds for machine-generated diffs. It was measured on human code in a different era. 5. Whether the 42% figure and the independent open source measurements are even, counting the same thing. They aren't. Quite. We used the 42, and we named who counted it. 6. What any of the documented migrations did to escape rate. 2 of those cut against this episode specifically. We cannot show you that AI code is worse, because that hasn't been demonstrated. And our headline share number comes from a vendor survey, which we've named as 1. If any of these gets answered, we'll say so on camera. Every source in this episode is in the description. If we got something wrong, tell us, and we'll say so on camera. Thank you for watching. Subscribe to AI Tech Book.